great civilizations of the past laid the foundations for our modern world. The Egyptians, Greeks, and Romans are celebrated as remarkable engineers, scientists, and innovators. But the history books have overlooked a magnificent period of invention when some of the greatest minds of antiquity would revolutionize scientific and technological knowledge. This is the incredible story of the machines of the East. The Eastern world is shrouded in mystery and intrigue. Often its history is lost to the West. But today, we are discovering that the technology and science that shapes our modern world has its roots in a remarkable civilization that spread throughout the ancient Eastern world over 1,000 years ago. Incredibly, they had ancient handheld computers that had many of the capabilities of modern satellite navigation systems. Massive water-moving machines that harness the power of the earth to transform dry deserts into rich and vibrant cities. Complex precision engineering that developed components that lie at the heart of many of today's machines. And awe-inspiring war devices, including fireproof uniforms and even the world's first torpedo, capable of destroying enemy ships from 1,000 yards away. For the history of Western civilization, the demise of the Roman Empire was a decisive turning point. While Europe slid into the mire of the Dark Ages, abandoning the incredible advancements of the great civilizations of antiquity, the lands of the East flourished. In the void left by the destruction of the world's greatest civilizations, important developments in the science of mathematics, in medicine, in literature, and the principles of engineering were made. What took place in a flourishing 500 years between the 8th and the 13th centuries, known as the Golden Age of Islamic civilization, is now making us rethink everything we thought we knew about the ancients.
Many of the scholars, engineers, craftsmen were amazingly innovative, and it was at a time of great creativity.
As the Islamic Empire spread from the Middle East to India, North Africa, and across Europe as far as Spain, scholars of the East absorbed the greatest collection of knowledge in the world. Incredibly, over the next 5 centuries, the lands of the East became the center of education and culture.
Europe couldn't have possibly reached where it did without the contributions of these people.
From the period, call it from 700 right further up to 1600 and beyond that, because it never stopped. It was a world of learning.
By the end of the 8th century, one school of learning would lead the way in technological and scientific development. It was known as the House of Wisdom, the ancient world's Harvard, or MIT. It attracted scholars from all over the Eastern world and became a nerve center for decoding the ancient texts that contained the designs and blueprints for machines that had existed over 1,000 years earlier.
Early Arabic inventors took many of these Hellenistic and Roman writings, copied them, but also added and elaborated and developed some of these principles further.
There are intriguing clues in ancient manuscripts that Eastern engineers inherited a tradition of building automata, the ancient world's equivalent of robotic devices. Modern engineers like Professor Al-Hassani of Manchester University in England are now studying ingenious machines like the tea-serving girl and are astonished by the masterly use of technologies that we still employ today.
The tea-serving girl principally is a tank on top of a robot. This tank has a hole that allows the water or the drink or the tea to come out of it.
By using a tank that regulates the flow of liquid, the machine builders were able to astonish and amuse their contemporaries. A reservoir is filled with liquid which drips at a constant rate into a bucket. When the liquid reaches a certain level, timed precisely to 7.5 minutes, it empties into the glass in the servant girl's hand. The weight of the glass triggers a mechanism that causes the servant girl to roll down a slope, opening the door and presenting the drink to the guests. This kind of trick device would have further enhanced the mystery and genius that surrounded the engineers of the time. From the examination of the ancient texts and archaeological evidence, we are now learning that, incredibly, Eastern engineers may even have been responsible for unlocking the secrets of the world's very first computer. At the start of the 20th century, a truly stunning discovery from the depths of the sea off the Greek island of Antikythera included the remains of the ancient world's most mysterious scientific object. Dating to around 100 BC, scientists believe that this may have been some form of analog computer. It is called the Antikythera mechanism. Its geared mechanisms have caused modern scientists to reevaluate ideas about technology in the ancient world. Despite being examined by some of the world's greatest minds today, exactly how it operated remains a mystery. But are there clues in Eastern texts that hold the secret to how this machine may have actually worked? A design for an 8-geared calendar dating from the 10th century AD has been discovered in a manuscript attributed to a scientist and astronomer known as Al-Biruni. Al-Biruni's machine harnessed the power of complex geared technology to track the movements of the solar system. Consisting of 8 bronze gear wheels that incorporated over 200 gear teeth, the machine was an outstanding technological achievement. All the displays were set to the correct astrological positions before the machine was ready for use. Each day, the user moved the alidade, or pointer, forward 1 division, turning the gears and gradually altering the positions of the sun, moon, and the shape of the moon's phases. The precision engineering of the bronze-toothed gears ensured the machine was incredibly accurate in calculating the days, months, and years. Could the Eastern scholars have been aware of the Antikythera mechanism? And did they possess the skills and craftsmanship to build sophisticated devices of their own? In a book written in the 16th century by the Eastern scientist Taqi al-Din is a mysterious machine that scholars now believe is an ingenious version of an advanced and extremely complex water-lifting device. This remarkable 6-cylinder monoblock pump, driven by water power, employs what appears to the modern eye to be 20th century technology and looks like a machine from the modern era. In Dubai, model makers have reconstructed this complex and awe-inspiring machine.
This machine is the 6-cylinder pump from Taqi al-Din. It's a water pump. It's driven by a grand water wheel. The water wheel is actually linked to an axis, or camshaft. The camshaft has 6 different cams on it. Each rod is linked at the end of the point with a weighted ball.
Opposite each cam is a lever arm, supported in the middle and pin-jointed at the other end to a vertical piston rod. The upper end of each piston rod carries a lead weight. The bottom of each piston cylinder has a clack valve. When the water wheel rotates, each lever arm is raised in succession by the cams. Water is then drawn up by the piston through the valve. When the lever is released, the lead weight ejects the water up through the delivery system.
It's a wonderful evolution from the Manab Musa brothers in the early 9th century, further down to where Al-Jazari was a fantastic ingenious engineer until Taqi al-Din for that particular era.
But it was not only ingenious scientific objects and instruments which would be built in the ancient Islamic world. Their scientists and inventors also created fully automatic mega machines designed to ensure the survival of millions, using technology not seen again for 500 years. By the 13th century, the inventors of the East had become world leaders in evolving new concepts of technology. The machines created during the golden age of Eastern civilization were designed to deal with ideas that were both complex and innovative. There is one inventor who stands as a colossus in the history books of technology. but his remarkable legacy is virtually unknown in the West. His name is Al-Jazari, and he created the definitive treatise on Eastern engineering. The text is known as the Book of Knowledge of Ingenious Mechanical Devices. So important was his work that today, without his descriptions, 500 years of Eastern technological advancement would have been lost. In the world-renowned Topkapi Museum in Istanbul, Turkey, is a rare copy of Al-Jazari's manuscript. The text was written in the year 1206 and contains within it the blueprints for many of the components that are key to modern engineering.
Al-Jazari, as his name says, comes from northern Iraq in the late 12th and the early 13th century. He was a very gifted engineer.
Al-Jazari's world covered some of the hottest land on Earth, and the master inventor would be acutely aware of the importance of water in sustaining life in the region. He turned his attention to creating a series of incredible machines, each of which would help his society not only survive, but thrive in these often arid landscapes. And it was in the design of water-raising machines that Al-Jazari made considerable advancements in the development of mechanical technology. What is stunning is that many of his machines match the principles of today's modern devices exactly.
He tried to take age-old standard technology for lifting water, for irrigation, and tried to improve them.
Previously, ancient devices for raising water, like the shaduf, often relied on animal or manpower to drive the machine. But the genius of Al-Jazari was that he replaced the need for manual power by designing a set of fully automatic lifting machines that used the power of the water itself to drive the mechanisms. One of the most intriguing is the device that has become known as water-raising device number 3. Until now, it was thought that this complex machine was simply an unrealized idea of Al-Jazari's that only existed as a concept in his manuscript. But amazingly, in Damascus, Syria, a new discovery has emerged that suggests that the remains of a water wheel found on the river Yazid is actually based on Al-Jazari's design, offering us a fascinating glimpse of his genius.
Al-Jazari was really a gifted practitioner. He was not only writing in his tradition, but he was really building them.
Built during the 13th century, the water wheel served the local community for over 700 years. Incredibly, it carried water to a local hospital until the 1970s, a testament to the machine's design and construction. Al-Jazari was a man who would often go back and improve his designs. This amazingly complete example is based on Al-Jazari's third design for a water-raising device and uses a complex system of gearing that is common throughout his work.
In his book, Al-Jazari mentions that this water-lifting device is designed to work by means of scoopers. That is, water falls down on the scoopers from a certain height, causing them to rotate. This in turn drives the pinions and axles which move the water-lifting buckets. This device has the same engineering principles, but rather than water falling, it works by horizontal water power in the Yazid River.
A water wheel is moved by horizontal boards, which cause rotation that drives gears, pinions, and axles to lift the water upward. The water was lifted some 40 feet to the top of the tower.
Up here, there are 3 wooden parts which have survived intact. A horizontal cogwheel was linked to a vertical cogwheel, which transfers the movement to a pulley, where a set of chains and buckets are installed.
The buckets carried water from the river up to the top of the tower, where it was discharged into an aqueduct to flow to the hospital. This incredibly well-preserved device is a magnificent example of the ancients' use of technology to improve the quality of everyday life for their citizens. But it was in Al-Jazari's design for his 4th water-raising machine that he would evolve the technology one step further and revolutionize mechanical engineering forever. It uses a crank system. This is the earliest known use of this technology in a working machine. The crank is described by modern engineers as the most important single mechanical device after the wheel. What makes this invention so incredible is that 500 years later, it would play an integral part in ushering in the modern age.
The use of the crank and connecting it to what we call a camshaft, this had revolutionized machinery and engines like the steam engines and the diesel engines and the petrol engines.
This simple mechanical component allows the conversion of continuous rotary motion into a reciprocating one. Hand-operated cranks had been known for centuries, but the incorporation of a crank-connecting rod system in a rotating machine was an incredible innovation. Modern engineers who have studied Al-Jazari's design have discovered that the horizontal axle of the machine is turned by gears and that the end of the crank slides in the hinged connecting rod, causing it to oscillate around its hinge and thus causing the water bucket to rise and fall. Until modern scholars decoded Al-Jazari's design, it was believed that this system was an invention of 15th century Europe. But remarkably, Al-Jazari was using this crank device in his machine 2 centuries earlier. There are other glimpses of huge water-moving devices which indicate that their technology had become widespread and extremely sophisticated throughout the ancient world. One of the most stunning examples of a fully automated device is an ancient water wheel, also known as a noria, many of which still survive today. The best preserved examples are located near Hama in Syria. Described by the Roman engineer Vitruvius, writing in the 1st century BC, the noria is a mega water-lifting machine.
The beauty of the noria is that it runs unattended, it's automatic, it uses natural forces to do the work for you.
These powerhouses have been calculated to raise up to 25 gallons of water per minute. These remarkable machines offer a fascinating insight into the much earlier norias that littered the ancient landscapes.
It's a water-driven wheel with compartments or buckets on the rim and paddles on the outside of the rim. The wheel is driven by water flowing underneath, and as the wheel goes round, compartments dip underneath the water, water enters through a hole in the leading edge, the compartment's carried up to the top of the wheel, and the water discharges into a trough or launder near the top of the wheel.
The diameter of the largest wheel is about 65 feet, and there are 120 compartments in the rim. The stunning designs of Al-Jazari and the beautiful surviving examples of mega water wheels from the East offer tantalizing archaeological evidence of the sophistication of technology available in the ancient world. But there are other mechanical devices from the Eastern world so advanced that scholars were unable to believe that this machinery was not created from 21st century technology. The machines of the East built on and furthered the technological advancements made during antiquity. In the ancient world, Greek and Roman engineers made remarkable innovations in mechanical engineering. Inventors like Heron of Alexandria and Philon of Byzantium were major influences on the work of great Eastern minds 1,000 years later. Scholars who are now translating the ancient Eastern manuscripts are beginning to uncover remarkable evidence that shows that we haven't discovered modern machines, we've just rediscovered them. What we are now learning is causing us to rethink the development of mechanical engineering. From the ancient world to the work of inventors like Leonardo da Vinci.
I'm quite convinced that the modern world would have developed in a very, very different way if Islamic civilization had never arisen.
We now know that one inventor from the East would change technology forever. Al-Jazari's final design for his greatest water-lifting device contained an amazing mechanism seen for the first time in history. Many people believe that the device known as the double-action suction pump was invented in the 20th century. In fact, it dates back to over 700 years earlier. Al-Jazari would look to his ancient ancestors for inspiration. Ctesibius, working in the city of Alexandria in Egypt in around the 3rd century BC, began the development of the principles of the suction pump. In the Technology Museum of Thessaloniki in Greece, modern engineers have constructed Ctesibius's pump using ancient manuscripts. Unbelievably, this 2,000-year-old design can still be found in use today in the fields of Northern Europe.
Here we have Ctesibius water pump. It's called a two-stroke water pump. It consists of 2 cylinders, each containing 1 piston and having at its bottom a valve, a water valve. The pistons are moving by the use of these handles here. As each piston moves upwards, it empties the cylinder from air, and its place, the air's place, is taken by water. The pistons are moving in opposite directions, ensuring that we have a constant flow of water. It was used from the ancient times till nowadays as a water pump, but we can say that it's the ancestor of a two-stroke engine, a motor engine that we use today, because if we replace water with a mixture of gas and air, we have the same principle in operation.
1,000 years later, Al-Jazari would take the principles of Ctesibius's design and develop them to new heights. While Ctesibius's machine relied on human action to pump water, Al-Jazari ingeniously applied his mechanical knowledge to create a pump that was fully automatic. This would have a direct significance on the development of modern engineering, and along with his crank system, would be used 500 years before the steam engine.
Take Jazari's machine number 5. It is actually a double-acting suction pump. It has got 2 cylinders with pistons reciprocating to the right and to the left.
The pump is driven by a water wheel, which drives through a system of gears an oscillating slot rod, to which the rods of the 2 pistons are attached. The pistons work in horizontally opposed cylinders, each provided with valve-operated suction and delivery pipes. The delivery pipes are joined above the center of the machine to form a single outlet into the irrigation system. Al-Jazari's amazing developments in the construction of water-moving machines soon led to other Eastern inventors and scientists taking the tradition further and building even more amazing devices. While Europe lagged behind in the building of complex machines during this period, engineering in the East was becoming even more advanced than we have previously thought.
There was a really vibrant tradition of mechanical science in the early Islamic world, in total contrast to Western Europe of the 7th to 9th centuries.
There were 3 brothers who led the development of technology and engineering in the East. They were known as the Banu Musas. Influenced by the translations into Arabic of ancient inventors Philan and Heron, the Banu Musas created a remarkable array of machines that advanced the work of their predecessors.
The science of mechanics was generally known as the science of tricks, because what one is doing, one is using mechanical phenomena to actually achieve what could have been impossible to achieve.
The key was a highly sophisticated application of hydraulic technology. By controlling air and water pressure, the ancients were able to automatically regulate their machines. The precise engineering techniques employed in this Banu Musa trick device would lay many of the foundations for modern mechanics.
This typical machine is effectively to give you an intermittent spouts of water or a drink. It uses very cleverly 2 new systems which were introduced in the early 9th century.
The first system is a ground conical valve, which is used to regulate the flow of water.
When the water is in the top tank, it will go through a hole in the bottom of the tank, like it is now doing there. In that hole, there is a conical ground valve that if it goes up, it would shut the hole.
The second is a feedback mechanism that controls the timing of the movement of the valve.
Because there is a siphon system in the middle tank, it will suck the water back into a smaller tank below. Now the third lower tank has a float. If the float goes up, then water will gush out. However, because it goes up, it will push that seating valve because it's connected with the seating valve, and then it will stop the water coming down from the top tank.
This device, and others like it, demonstrate an amazing knowledge of the use of differential pressures. Exactly the same techniques are used to control mechanisms in everything from washing machines to jet engines today.
We have seen an emergence of a civilization which has influenced our present-day civilization enormously in our homes, in our hospitals, in our schools. And even when you look up the sky, a lot of the stars are still named by Arabic names.
In addition to hydraulics, we have intriguing evidence that the peoples of antiquity also had the technology to accurately calculate the movements of our Earth, Moon, and Sun. This was vital for navigation, religious ceremonies, and understanding the passage of time. One incredible device, first developed in Hellenistic Greece in around the 2nd century BC, was to reign supreme for over 1,500 years. It was called the astrolabe. The Museum of the History of Science in Oxford, England, houses the largest and most important collection of astrolabes in the world. Its curator is Dr. Stephen Johnston.
An astrolabe has been called an ancient pocket computer. Its primary use is in telling the time working with the sun and stars, so it comes from astronomy. It can tell you when the sun rises, when the sun sets, for any day of the year, wherever you happen to be.
However, it would be the Eastern scholars who developed and improved the astrolabe's capabilities.
In the 8th, the 9th, the 10th centuries in the Eastern world, the instrument was developed, new variants were devised which were more powerful, which could be used not just in one place or a small selection of latitudes in the world, but could be used universally.
The portability and accuracy of an astrolabe made it something like a modern-day BlackBerry of its time.
This is the oldest astrolabe in the museum's collection, dates from the late 9th century. But it's more than just a calculating device. If I turn it round to the back, this is an observing instrument. And if I hold it up, you see how this was used to measure the height of the sun and the stars. I'd adjust that ruler until I was looking through and seeing the star through the little pinhole sights that there are here. Then when I've done that, I read off from the pointer the degrees. There's a scale of degrees going around the edge. That tells me how high something is in the sky. When I've got that, whether it's the sun or a star, I can get the time.
The inventors of the East had become masters in the art of mechanical engineering. Eastern cities were the powerhouses of technological innovation. Inventors like Al-Jazari now turned their attention to even more intricate engineering challenges, using the knowledge they had evolved to create complex mechanical clocks and amazing military devices. The work of the inventors and scientists of the Eastern world began to develop technology that today still has a major impact on our lives. The great inventor of the East, Al-Jazari, in his 13th century treatise, The Book of Knowledge of Ingenious Mechanical Devices, began to develop mechanical principles that would take us into the modern age. The text is one of the most important records of engineering developments from any culture before modern times. It contains the designs for over 50 machines, each described in meticulous detail, in order that other engineers could take them as blueprints and build these often complex devices. We have challenged leading British model maker Richard Windley to recreate one of Al-Jazari's ingenious automated machines, a device which used a candle to accurately calibrate the passage of time.
He even laid down the materials the candle should be made from, the precise dimensions of the candle, and even the materials that the wick of the candle should be made from.
Al-Jazari describes 4 candle clocks in this treatise. No other examples of this sophistication are known.
It works on the basis of a candle slowly burning and altering through a series of pulleys and cords a dial from which the time could be read off. The Islamic day was divided up unequally. The daylight hours and the nighttime hours were different, so that made the whole system even more complicated.
But Al-Jazari's solution was deceptively simple.
And what we've basically got is the candle burning away, being pushed upwards. As the wax melts and burns away, the candle gradually rises. This lead weight is going to descend like so, and in the process pulls this cord here, which passes over a pulley and round an axle shaft. This is the shaft that's connected to the pointer on the dial from which the time can be read off.
This stunning example of a small-scale precision timekeeping device also uses a simple mechanism found in many modern households today.
It's fairly important that there's some sort of device to hold the cap against the pressure of the weight underneath. And what Jazari did was to use a little kind of L-shaped clip system. And in fact, this is almost identical to what we have nowadays in the electric light bulb, what we now call a bayonet fitting. It's curious that after sort of 1800 years we're still using an intrinsically similar device.
But there's more. One of the most elaborate sections in the Book of Knowledge of Ingenious Mechanical Devices is dedicated to water clocks that demonstrate the principles of hydraulics. In these pages are detailed some of the world's most complex mechanical devices for measuring time. One machine in particular was an outstanding technological achievement that still poses challenges to modern reconstructors. Today it is called the Elephant Clock. In the Ibn Battuta Mall in Dubai, MTE Studios have recreated a large-scale working replica of Al-Jazari's masterpiece. With a team of over 150 experts working on this 23-foot-high, 7-ton mega clock, the project was a massive undertaking that required over 11,000 man-hours. Ludo Verheyen is the director of the Al-Jazari Elephant Clock Reconstruction Project.
This project was quite a challenge because indeed it was the first time that these features have been reconstructed ever. It is complicated. The inventor from 800 years ago, Al-Jazari, was a great inventor, so to learn from his manuscripts in a very accurate way how the mechanics actually worked is quite fabulous.
But how does this complex and awe-inspiring device actually work? And how did Al-Jazari improve so fundamentally on the timing devices of his ancient forefathers? Amazingly, the elephant clock consists of several mechanisms that match those used in modern engineering. Inside the belly of the elephant is a submersible float with a small hole which is carefully calibrated to produce a specific flow of water which determines the rate at which the float sinks, and therefore the time at which the clock strikes. The sinking activates a tripping mechanism which sets a series of events in motion that mark the passage of time and strike the hour. At this point, the float is tilted out of the water, emptying its contents. It will then rest on the water's surface and the cycle is repeated. The clock employs automata such as the striking of a cymbal and the chirping of a bird to mark the passage of the hours.
For its time, it is a very complicated clock in the sense that it has automatic feedback, and this continues almost like a perpetual motion machine.
The elephant clock is one of the finest examples of technology from the golden age of Eastern civilization.
So it's a unique combination of art and architecture and also engineering.
But the inventors of the East also turned their attention to the development of machines of war. In order for this great civilization to spread so rapidly, its engineers must have developed a formidable array of weapons. The Eastern world was responsible for bringing the technology of the trebuchet to Europe from China, the most feared war machine of the ancient world.
The military equipment that you would have found being used in the 12th and 13th century in the Islamic world would have been of considerable superiority over what would have been used in Europe at the same time. The counterweight trebuchet could hurl a much larger weight of almost 400 pounds, and it could hurl it to a distance of about 300 yards. Not simply stones or large, heavy pieces, but also incendiary devices.
But it was not only catapult technology that spread from China, for the war engineers of the East were responsible for far more advanced discoveries, including fireproof uniforms and explosive weapons. One weapon in particular would change the face of war forever: the torpedo. The engineers and scientists of the East had made huge pathways in developing intricate technology that built on and furthered the innovations of ancient civilizations. But the great minds of the East are also responsible for the development of ingenious and terrifying weapons of war. And used in these weapons was a sophisticated form of refined gunpowder. This was manufactured to a formula that used natural ingredients which were in plentiful supply. These included willow charcoal and saltpeter.
By combining them, you turn relatively innocuous components into the driving force of warfare for nearly 1,000 years.
Gunpowder was invented in China, but in its early stages of development was not explosive enough to be deadly on the battlefield. But now, new evidence suggests that scientists of the East devised a formula that could actually be harnessed for the theater of war.
It's not until the 12th century, 13th century, when we start to get the mixtures refined to such a way as you can effectively drive rockets, torpedoes, cannons, handguns, and everything we're familiar with ever since. But it was Hassan al-Rama who was the man who really put it down in writing and made it clear.
Working in the 13th century, Hassan al-Rama wrote an infamous book on military technology, detailing explosive recipes for gunpowder. So advanced was his thinking, we may have to re-examine the history of warfare. For within the pages of his book, Hassan al-Rama documents what is believed by some scholars to be the first rocket in history developed specifically for warfare.
He lists 22 different recipes for the powder for rockets and different forms of rocket. He's really the father of rocketry.
During the same period of innovation, Eastern war engineers also developed another weapon that harnessed the explosive capabilities of gunpowder: the cannon.
In Spain and North Africa, at the end of the 14th century, there were people who were using the purified and crystallized form of saltpeter in a container, if you will, which was then lit as an explosive to project a small ball, and we have evidence for this from as early as 1377.
There are intriguing images which still survive of Eastern forces carrying such cannons. In one early text from the St. Petersburg collection known as the Book of Sciences, a description is provided of a soldier who carries a midfa, or cannon. The weapon looks like a modern handheld rocket launcher.
Now, in the St. Petersburg manuscript that describes the uses, serious and for entertainment, as the title says, of gunpowder, we see pictures of a small barrel on the end of a stick. This is a hand cannon, or even the forerunner of a hand gun. This is the basis of the weapons that are carried by every soldier today.
But incredibly, the manuscript contains even more clues to the sophistication of warfare in the Eastern world: the use of fireproof clothing.
This is reconstructed based on the St. Petersburg manuscript. We start out underneath with silk tunic. We know that silk's fireproof. Even today, Formula One racing drivers wear silk underneath their Nomex fire suits. On top of that, we've a quilted garment. To a Western warrior of the time, it'd be known as an akaton. That comes from the Arabic al-kutun, meaning stuffed with cotton. But the key part is this on top, which is a woolen overtunic, a fireproof, indeed chemical-proof layer, similar to the nuclear biological warfare suits that a modern soldier would wear on the battlefield.
The manuscript illustrates warriors with incendiary devices covering their clothing. This would have created a terrifying firestorm as they were ignited just before the warriors charged into the ranks of enemy cavalry.
The incendiary charges are something like this. They describe linen fibre. This is linen fibre, flax, and just a twist of that linen fibre, and in here, a nice bundle of gunpowder, black powder. These are shown on the illustrations of the manuscript, fastened to the fireproof clothing. It also says how they're fastened together with wire. This wire holds the linen fibre, but also allows it to be pushed and fastened onto the garment.
But But how effective would this form of protection have actually been? Using original materials, we put it to the test.
Of course, there'd be literally hundreds of these going off on different men. That would be really distracting to the horses. But for me, the most interesting thing is not even a scorch mark. In fact, it's hardly even warm inside. Fireproof clothing really does seem to work.
But incredibly, one device recently discovered in the ancient texts has caused us to revisit our ideas about concepts of warfare in the Eastern world.
There are some interesting comparisons to make between these medieval military technologies and much more modern ones. One that particularly comes to mind is the design for what we might call a torpedo.
It was called the egg which moves itself and burns, and it is now believed that this weapon was the first torpedo in history.
It's an anti-shipping device. Unlike a modern torpedo, it didn't slide along under the surface, it skimmed along the surface.
But did the war engineers of the East really possess the skills and knowledge to build such sophisticated devices?
Until recently, we believed that the torpedo was a 19th century invention. So to learn about a precursor to this from 700 years ago really causes us to sit back and look again at history, particularly the history of naval warfare. This is a torpedo. How effective it is, we don't really know.
To try to answer this question, we challenged model maker Richard Windley to test this marvel of Eastern technology using a design based upon the original 13th century blueprints.
The model I have here has been constructed based on illustrations from one of the early Islamic texts from around about 1220. The text talks about a pear-shaped device, or a flattened pear-shaped device. This is made out of copper and iron plate. The main tube running across the top of the vessel is the holder for the black powder charge. The point was so that if it hit a wooden vessel like a ship, it would impale itself and make removal fairly hazardous. Basically, when we're talking about a rocket, what we're talking about is a cylinder which is filled with compressed gunpowder. These are very similar to fireworks that we use today, and in fact similar to fireworks that the Chinese were making hundreds and hundreds of years ago. This one I've used a sort of fairly novel construction underneath, but it probably would have been hammered iron to produce this kind of flotation vessel.
This would have been filled with an incendiary mixture. Used as a weapon of terror, the torpedo would have had a devastating effect on enemy vessels. But could this ancient device have really possessed such incredible powers of destruction?
What we think may happen is that as it picks up speed, it may kind of aquaplane, so it will probably rise out of the water as it gathers momentum. The two long rods either side are for stability, so they're acting as a kind of rudder. It also keeps the device in a stable attitude in the water. We're using a conventional fuse. It's simply a cotton thread soaked in gunpowder and then dried out. It's what's known as a delay fuse, so we've got just over a second per inch. Brilliant, that was absolutely amazing. These guys were perfectly capable of making fairly formidable weaponry.
Although we may like to believe that after the demise of the Roman Empire, ancient technology was lost to the Dark Ages, we would be wrong in thinking so. New insights from historians and modern engineers have revealed that the lands of the East inherited and furthered the development of science and technology to new, incredible heights.
I think they were almost more free-thinking in terms of technology certainly than the Romans, maybe even more than the ancient Greeks.
In the years to come, as more Eastern manuscripts are studied, we will uncover more awe-inspiring machines and we'll have to reconsider who were the great technological innovators that shaped our modern world. As our new knowledge of the ancients will cause us to rewrite the history books, we will have to admit that we haven't invented our mechanized world, we've just reinvented it.